Hello everybody and welcome to emintolucanedu.com. Today we are going to have our first math course. This course is created for students in order to allow them to achieve good scores on the SAT math section. Along the way we are going to cover many tips and tricks and strategies on how to achieve good scores on the SAT exam by being able to solve questions easily. The topic of today's discussion is linear equations and inequalities, graphs and word problems. This topic is extremely important, especially because the SAT is built on linear equations, and this topic will cover at least 10% of the SAT exam's mathematics questions. In order to introduce ourselves to the basic algebra of the SAT, we need to understand the analysis of graphs, construction of linear equations and inequalities, analysis of linear equations and inequalities, analysis of higher order equations, like polynomials or quadratic equations, and we need to be able to solve equations and inequalities. We need to understand that basic understanding of graphs is extremely important on the SAT exam. Today we are going to start with basic terms that you need to know related to Cartesian coordinate system. In mathematics, we usually use the Cartesian coordinates as opposed to cylindrical or spherical coordinates. And the SAT exam includes questions related to this coordinate system. The first term that we need to know is the x-axis. X-axis is the horizontal line here. Now, y-axis is the vertical line of an xy graph, so this is the vertical line. Now let's talk about the origin. Origin is the center here. Point 0, 0 will be our origin. Some people do not know this, but origin is actually the center of the Cartesian coordinate system. Y-intercept is the point at which a line crosses the y-axis. For example, this purple point. Some graphs may have two y-intercepts, right? But we are not dealing with such graphs. Today we are going to deal with linear equations, and linear equations have one y-intercept. They can only pass that y-axis once. And finally, x-intercept. Well, obviously from y-intercept, where that is the point at which the graph crosses the y-axis, we can determine that x-intercept is the point at which a graph crosses the x-axis. For example, this line crosses the x-axis at approximately -1.9. Parabolic shapes like this may have one or more x-intercepts, and graphs of equations of higher order, like a polynomial, may have even more x-intercepts, right? So that is just for you to keep in mind. Now, let's talk about the equation of a line. Obviously, we know that whatever we can plot on a graph may have an equation. And of course, lines have their own equations as well. The equation is of a form y is equal to m times x plus b. Here, y is our vertical coordinate. M is the slope, and we are going to talk about this in detail in a few seconds. X is the variable, or the horizontal location of a point, and of course b is the y-intercept. We just talked about the y-intercept. That is the point at which the line crosses the y-axis. So we are going to talk about all of this in detail, but here we have 3 stars, and whenever you see 3 stars in these classes, please know that you need to memorize this equation by heart, because it is not provided on the SAT exam, and it is going to be of great use for you on the SAT exam itself. You are going to use this equation, and you're going to stumble upon equations of this form a lot. But for now, let's talk about this m, slope. Slope m is a constant number for linear graphs that describes how fast the line goes up or down. Basically, what I'm trying to say here is that how steep a line is will depend on its slope, right? So this angle right here, angle of inclination of a line, will depend directly on that letter m that will be described further. Sometimes on the SAT, slope is called rate, rate of change, rate of increase or decrease, or increase per unit time. For example, increase in cost of renting a boat per an hour, or increase in cost of living in America per year. This increase, whenever you see this word, this should be your clue that we're talking about the slope or the rate of change. And slope has an equation as well, and it goes like this: y2 minus y1 over x2 minus x1. Sometimes we also say rise over run. Now, what does that mean? This means that if you have a point of coordinates x2, y2, and if you have some other point of coordinates x1, y1, then you can create a line between those 2 points. And that line is going to have a slope m is equal to y2 minus y1, so the difference in the vertical coordinates, divided by x2 minus x1, the difference in the horizontal coordinates. To be precise, here we have coordinates 3, 4. That is, the x coordinate is 3 and the y coordinate is 4. And for that point we have coordinates 1, 1. So if you want to find the slope of this exact line, slope will be y2 minus y1, and we pick the upper point as the second point because that makes it easier for us to calculate the slope. So 4 minus 1 divided by 3 minus 1. Well, that gives us 3 over 2, and that is just 1.5. So this is the way we can calculate a slope for a line. Now there are different terms for slope. So slope can be positive. That is, if m is larger than 0, for example 1, 2, 3, 4, and so on and so forth, the line has to go up. So it looks something like this. We may also have a negative slope. If m is less than 0, then we have a negative slope. That is, m can be -1, -2, -3, and so on and so forth. Here, the line is going down. That is, if we go from left to right, so like this, the line is going downward. It's facing downwards. So any line with a negative slope will be going down like this. And it doesn't matter. Maybe the slope is negative, but it's small. So still, the shape of a line will be something like this, right? Or maybe something like this. This indicates that the slope is negative. Now, what happens when we have a zero slope? That is, there is no slope at all. Well, then we have a constant line that is horizontal. So m is equal to 0, the line is horizontal. And here we are going to discuss constant graphs. So when y is equal to constant, for example, y is equal to 3, we may have a horizontal line. This is what we just discussed. Here the slope is 0. Now when x is equal to a constant number, for example, x is equal to 1, that means we will have a vertical line that passes through x is equal to 1. So please keep this in mind. Now, recall that we said that slope can be also named as the rate of change. So sometimes on the SAT, when you stumble upon the word rate of change, this expression indicates that the question is about the slope. And slope can be characterized as steep or almost horizontal, right? So here, the steepness of the slope decreases from pink to purple to orange, right? So the slope is decreasing like that. And finally, the line may become perfectly horizontal. Now let's look at an example. According to the graph above, between which two consecutive years, well, consecutive means one after the other, for example, 12, 13, 15, 16, right? So here we have 2003 and 2004. Well, anyway, between which two consecutive years was there the greatest change in the number of 3D movies released? Well, we see here change, so greatest change. Well, this indicates that the question is asking for the greatest slope. Remember, we said slope is a rate of change, greatest change, smallest change. Smallest change is here. There is no change, right? It's absolutely horizontal. Between years 2003 and 2004, number of 3D movies released didn't change, so it was 1. But when we look at years 2010 and 2011, there is a rapid growth, right? So there's a growth, and that indicates that when the line is almost vertical or close to vertical, right? Close to vertical like this, we have the greatest change. That means between years 2010 and 2011, there was a rapid improvement in the release of 3D movies. Well, the answer to this question then is D. Now let's talk about y-intercept. Remember we said y-intercept is the point at which the graph of a line crosses the y-axis. Well, in the equation of a line y is equal to mx plus b, y-intercept is characterized as b, so it's a constant and it's added to slope times x. For example, for the equation y is equal to 2 times x plus 3, we would have y-intercept at point 3, and since slope is 1, for each unit to the right, so for each unit to the right, we would go 2 units upward, right? So this would be our second point. Now, in a few seconds, I will tell you how to draw lines given the slope, but for now you have to know that connecting those lines will just be enough. Connecting those points would just be enough to get our line. So this is our purple line that is characterized by this exact equation. Here you can see that y-intercept is 3. Now let's give another example. Y-intercept can also be negative. For example, y is equal to negative 2x minus 3, right? So here we have y-intercept of minus 3. That means line passes through this point and it has a slope of negative 2. So for each unit to the right, we go 2 units downward and we put another point. Then we connect those 2 points like that and we get our line. So this is our line. The red line is characterized by this exact equation. Now let's look at a question. Sometimes on the SAT exam, you're asked to construct an equation from a given data and solve that equation. As an example, we may get a question like this. So we're given a table of x values like 1, 3, and 5, and f of x, so y values, that is function of x, 5, 13, and 21. And we are asked, some values of linear function f are shown in the table above, which of the following defines that f, that function. So which one of those is the equation that would allow us to create a table like this? Well, the best way to solve such questions is to first find the slope from the data here. Now, we know how to find the slope. The equation of slope goes like m is equal to y2 minus y1 divided by x2 minus x1. Now pick any point. Here we have points 1, 5, and here 3, 13, and here 5, 21. Now let's pick this point as the second point, and let's pick this one as the first point. Then we are going to get a slope of m is equal to y2, which is 21, so 21 minus y1, which is here 5, right? Divided by x2 minus x1, so 5, this is x2, minus 1, this is x1, so 5 minus 1. And that gives us 16 over 4. We know that 16 over 4 is equal to 4. And the only linear equation in the answers with the slope of m is equal to 4 here is choice C, right? So C is the correct answer. But we may get a different case here. What if they had two choices that contained slope 4? So for example, what if the answers were not this type, but one of the answers would be f of x is equal to 4x minus 1. And we have now two answers with a slope of 4. Well, what do we do then? Then we must look at the y-intercept, right? Which one of these is the correct y-intercept? So let's take a look here. We have already found that in the equation y is equal to m times x plus b, m is going to be 4. So let's rewrite y is equal to 4 multiplied by x plus b. Now we're trying to find b. In order to find b, we can plug any of these values, for example, any of these points into this equation, y is equal to 4 times x plus b. Let's plug f of x is equal to 21 and x is equal to 5. So 21 is equal to 4 multiplied by 5 plus b. From here, we can simplify 21 is equal to 20 plus b. Well, therefore b has to be 1. b is equal to 1. And we can replace this b here by 1, right? So our equation is y is equal to 4 times x plus 1. C is the correct answer. So this is what you do when you stumble upon answers where two slopes are the same. But my advice to my students, and it's actually very important, that you start from the slope. Find the slope using the equation m is equal to y2 minus y1 divided by x2 minus x1, and from here you will be able to determine the correct answer. Now let's talk about perpendicular graphs. Well, sometimes on the SAT you are asked to find the equation of a line that is perpendicular to some other line. And when we say perpendicular, we mean two lines have an angle of 90 degrees between them. In order to do that, let's give an example. Let's say you have a line y is equal to 2 times x plus 1, right? And it looks something like this. So we put a point at 1, then we jump 1 unit to the right, and since slope is 2 units upward. Here we have our second point. So we need to connect these 2 points. So the line should look something like this. Now we are asked to find the line that is perpendicular. So some black line that is perpendicular, that has a 90-degree angle with the red line. Now, how do we find the equation of this line? How can we do that? Well, the first thing that we need to find is the slope of that black perpendicular line. To find that slope, we need to take the negative reciprocal of the slope of the line that you already have. So we have the equation of the pink line, and that slope is m is equal to 2. So m is equal to 2. In order to find the slope of this black line, y is equal to mx plus b, we take the negative reciprocal. That is, we divide 1 by that slope m, so that is 2, and we change the sign, so minus 1 over 2. Now the slope of that black perpendicular line will be negative 1 over 2. Again, I will repeat myself again. In order to find the slope of a line that is perpendicular to y is equal to 2 times x plus 1, you need to take the slope of this pink line, and that is 2, and you take the negative reciprocal. So you divide 1 by that slope, which is 2, and change the sign to negative, right? So your new slope, the slope of the black line, is going to be y is equal to negative 1 over 2x plus some y-intercept b. Well, in this case, right, the y-intercept is 1 because the line is passing through point 0, 1. So this line's equation is y is equal to negative 1 over 2 times x plus 1, right? So that's the black line. Now, what if a line has already got a negative slope? So, for example, this line right here, y is equal to negative 1 over 2x plus 1. And we need to find a line that is perpendicular to this pink line, so something like this. How can we do that? Again, we look at the slope of that purple line, the line that we already have and the equation that we already have. The slope here is negative 1 over 2, so we flip that. We take the negative reciprocal of that, right? And when we flip it, the slope is going to be just 2 over 1, right? We flipped it, so we flipped it. And we changed the sign, so negative reciprocal. We flip and change the sign. It was negative, now it's positive. So it's basically going to be 2. So y is equal to 2 multiplied by x plus that y-intercept. What is the y-intercept here? It's 1. So y is equal to 2x plus 1 is our equation of the black line. Now, what if the equation is not in its original form? So we see here there is something different. The equation of a line that we have covered has a form y is equal to m times x plus b. Well, what is this then? Don't be afraid in such cases. What we need to do in order to find the perpendicular line to some line of this equation, we first need to convert this to the original form y is equal to mx plus b. So let's do it. Let's rearrange the terms here. So send y to the right side, we get 3y is equal to 2x, well, negative becomes a positive when we throw it to the other side, plus 6. Now let's leave y alone. This is our purpose. Y has to be alone. It has to have a multiple of 1. And therefore, let's divide every term here by 3, right? This way we will be able to leave y alone. So y is equal to 2 over 3x plus 2. This is our equation of a line in the original form. So that's this line. Y is equal to 2 over 3x plus 2. Now our purpose is to find an equation of a line that would be perpendicular to this. So what do? We take the negative reciprocal of the slope. So that line would have a slope. Well, we flip the numbers here. Denominator becomes numerator. Numerator becomes the denominator. So we flip. We get 3 over 2, and since it's a negative reciprocal, we also add a negative here, right, times x plus some y-intercept b. Well, in order for a line to be perpendicular to some other line, it does not necessarily have to have the same y-intercept. It can be perpendicular anywhere, right, anywhere. Therefore, that y-intercept is not always important. Now, you may notice that answers have a form like this. So they do not have a form y is equal to mx plus b. They have some other form. That's why we need to convert our answer to that form now. So let's add negative 3 over 2x to both sides. What we get is 3 over 2x plus y is equal to b. Now, in order to get some sensible answer, what we need to do is we need to get rid of this denominator. So what do? We multiply every term in this equation by that denominator in order for that to cancel out. So what we get is 2 cancels out with 2. So we get 3x. Then 2 is multiplied by y. So we get plus 2y is equal to 2 is multiplied by b. So 2b. Now again, do we care about this? We don't care. It's just a constant number. The answer that contains 3 times x plus 2 times y is the correct answer. Well, in our case, it's a, right? So this is the way we find the equation of a line that is perpendicular to some other line. Now, let's talk about another concept, a zero of a function. Sometimes on the SAT they say what is the zero of some function, for example some line. When they say zero of a function, please keep this in mind. You have to think about the x-intercept of that function. So the zero of a function is, or are, if there are many zeros, the x-intercept of a function. Let's give some examples. So for this function, this line here, the 0 or the x-intercept is x is equal to 0. For this function, it is x is equal to 3. And in the 4th class, we're going to be talking about parabolas. So for parabolas, you sometimes may have 2 zeros. So here we have 0, and here we almost have 3, right? So it may cross the x-axis on more than one point. Now let's practice. Please pause this video in order to be able to solve each question by yourself, and then unpause it to see my solution. Question number 1. Which of the following is the graph of the equation y is equal to 2 times x minus 5? Well, first thing we do is we look at the y-intercept in such cases. Y-intercept is negative 5, so line must cross the y-axis at negative 5. Here, line is crossing the y-axis at 2.5, so this goes away. This cannot be the answer. And here, it's crossing the y-axis at 5, so this is also not the answer. Now, we are left with two answers, B and D, two choices, right, that contain a line that crosses y-axis at negative 5. The second thing that we must look at is the slope. Since here the slope is positive, right, the line has to go, so to say, upwards from left to right, and therefore choice D is the correct choice. Second question. Try to solve this by yourself. Now, the graph above shows the distance traveled d in feet by a product on a conveyor belt m minutes after the product is placed on the belt. So on x-axis we have m, that is time in minutes, and on the y-axis we have the distance in feet, right? And that's d. Which of the following equations correctly relates d and m? Well, here we need to understand that instead of y is equal to m times x plus b, we have d is equal to m times m, which is slope times the variable plus b. Now be careful, this m here, it's a constant number. This m here is a variable, so they're different. Multiplication doesn't give you m squared. Please be careful. Now let's find the slope here. For 1 unit to the right, we go 1, 2. 2 units upward. So rise over run, right? How many units you go up divided by how many units you go to the right? Well, that's just 2 over 1. That is 2. Slope is 2. So d is equal to 2 times m plus b. Now, what is b? What is your y-intercept here? We can clearly see that the line passes through point 0, 0, right? So here your b is going to be 0. d is equal to 2 multiplied by m, and that is your answer. Your answer is A, and that is the equation that describes this line. Now, let's try to solve the third question here. In the xy plane, the graph of which of the following equations is a line with a slope of 3? Well, we know that slope in the equation y is equal to m times x plus b is m. And if slope is 3, then y is equal to 3 times x plus any b will be the correct answer. Here we have c, right? So y is equal to 3 times x plus 2. Let's go with another question. The table above shows some values of the linear function f. Which of the following defines f? Now, here you may notice that we have already solved this type of question, and in here my advice was for you to first determine the slope. In order to determine the slope, we use the equation m is equal to y2 minus y1 divided by x2 minus x1. And here we can pick any point as the second point, for example this one here, function of n and variable of n, so x comma y or n comma f of n, right, would be our second point. Now let's pick the first point. This one looks okay. So this is also the first point. Alright, now let's find the slope. M is equal to, well, here we got y, but we can convert it to f of n2 minus f of n1 divided by n2 minus n1. So f of n2 is 7 and f of n1, function of n1, is 1. Now n2 is 4 and n1 is 2. So the slope is the division of those subtractions, differences, right? So that's 6 over 2. Therefore, the slope here is 3. Now, which of the choices has m is equal to 3, slope is equal to 3? The only choice that contains slope is equal to 3 is C. So C is your correct answer. Now, let's think about a concept of slope as a fraction. For example, sometimes on the SAT exam, you may stumble upon functions like this. Y is equal to negative 3 over 2x plus 1. How do we draw those lines? Well, the idea here is that denominator of the slope fraction will be your run, so movement to the right, okay? So that's your movement to the right. And the numerator here is going to be rise. So that's how much you go up or how much you go down. The rise, right, so how much you go up or maybe how much you go down depends on this sign. If this is negative, that means you will go down. If it's positive, that means you will go up. So we put a point at the y-intercept. So this is your y-intercept and we put our first point here. After that, we are going to run. So we run 2 times, right? So 1 and 2. And we are going to rise. Now, since it's negative here, we are going to fold 3 units. So 1, 2, and 3. And this will be our second point. By connecting these 2 points, we will get the line that would describe this equation. So the orange line here is the curve described by this equation, y is equal to negative 3 over 2 times x plus 1. Now let's repeat it. We started at the y-intercept. We went running, so 2 units to the right, right? So run is the denominator, 2 units to the right, and rise or fall. So if it's negative, then we fall. So 1, 2, 3 units falling, and this is our second point. Now let's have another example. Let's say we are interested in the graph y is equal to 4 over 3x plus 2. What we do here is, again, we start at the y-intercept and we go running, so we go 3 units to the right, denominator units to the right, and, well, 4 units upward, because now we rise, it's positive, so we go up 1, 2, 3, and invisible 4, somewhere here. And we connect the dots now, so the line will look something like this, right? Please keep this in mind. So now we have covered linear equations. And this was basically everything you needed to know to solve easy, medium, and hard problems related to basic linear equations. And right now we have another very important thing to cover, and that is systems of linear equations. You may have heard of a concept of systems of linear equations before. And right now we're going to discuss why this topic is very important for the SAT exam and how do we use it. Now let's introduce ourselves to the concept of systems of linear equations. A system of linear equations, right, is when you have 2 or more lines on the same plot described by linear equations. So basically saying, when there are 2 or more linear equations somehow related to each other, that is, maybe they're on the same plot, right? So we call this a system of linear equations. Here we have a system of linear equations. We have 2 equations that describe lines plotted on the same plot. Now you may see that they are related to each other. That is, they have an intersection, so they cross each other at this point. Now, when 2 lines cross each other at some point, we call this an intersection, and you will see that it's a solution of a system of linear equations. A solution of systems of linear equations is the point x comma y where the 2 linear equations cross each other. Well, maybe you have more than 2 lines, maybe you have 1 million lines and they cross each other at that point. That would be the solution of 1 million equations, right, that cross each other. But here in the only SAT exam, we're only dealing with systems of 2 equations, and therefore you don't need to worry about anything. The point here is that point, so it's 1 comma negative 1, may satisfy, that is, make these 2 equations equal to each other in such a way, right, when you plug the x coordinate here. So for example, plug x coordinate 1 into this equation, y becomes negative 1, right? So 2 minus 3 is negative 1. And again, plug this x coordinate into this equation, and what you will get is, again, negative 3 times 1 plus 2, that's y is equal to negative 1. So you get y is equal to negative 1, y is equal to negative 1, x is equal to 1, x is equal to 1. This is the point where 2 lines cross each other. Now we may ask ourselves, how many solutions may such a system have? Of course, we need to introduce ourselves to as many case scenarios as possible for the SAT exam. And it turns out that there are 3 cases. A system may have 1 solution, no solutions, or infinite solutions, that is infinitely many, like millions, billions of solutions. Let's take a look at each one of those one by one. When a system has 1 solution, that means there is 1 point where 2 lines intersect, that means cross each other. And usually we can determine where this point is, so we can determine its x comma y coordinates. You may notice that for a system to have 1 solution, that is for 2 lines to cross each other at some point, you must have different slopes, alright? So the slopes of those 2 lines are different. One of those slopes is positive and one of them is negative, and it's always like this. one slope has to be positive and one slope has to be negative for two lines to cross each other at some point. Now the second case here is when a system has no solutions. In that case, we say that slopes are the same. So for two lines, the slopes are same, so they are parallel. Please remember that relationship. When two lines are parallel, well, they have no solutions. This system has no solutions. That means these two lines, they never cross each other. They do not cross each other. They're always parallel. Well, slopes are same. That's the first condition. And y-intercepts are different. That is the second condition. When these two conditions are satisfied, right here we have different y-intercepts. When these two conditions are satisfied, we can say that a system has no solutions. And the third case scenario is when you have two absolutely same lines plotted on the same plot. That is, if you have y is equal to, for example, 2x plus 1, this is just an analogy, right? And 2y is equal to 4x plus 2. Although these two equations are written in a different form, here you have a multiple of 2, these two equations are absolutely the same. Their y-intercept is the same, right? And their slopes will be the same if you just divide everything by 2 here. And therefore, these two equations will lie on top of each other. That means they will cross each other infinitely many times. And that means that system has infinite solutions, so infinity. Now you may wonder, alright, so we know three scenarios where systems of equations may have one solution, no solutions, or infinitely many solutions. But how do we solve that? How do we find that point without knowing the graph? Well, there are three ways to solve systems of linear equations. First one, of course, is graphing, and it's obvious. We've been using graphs so far. The second method to solve systems of linear equations is substitution, and we will talk about it in a few seconds. Last but not least, we have the elimination method. Now we must know when to use each one of those because there are different cases, and therefore we must be aware of situations when one of those has to be more efficient and faster and easier to use. So let's talk about solving by graphing. We graph the first equation and then graph the second equation. After that, we find the solution by looking at the point where two equations intersect. But before we graph, we must bring two equations into the form y is equal to mx plus b in order for it to make it easy for us to graph. Now let's see an example. Here you have x plus y is equal to 3. Now let's bring this to the form y is equal to mx plus b. Leave y alone, throw x to the other side. Y is equal to negative x plus 3. And let's graph it right now. So y-intercept is 3 and slope is 1 to the right, 1 down, negative 1 right. And so we need to connect the dots. So let us connect the dots here. Well, this is the perfect graph of this equation. And now let's do the second one. So x minus y is equal to 1, leave y alone. Negative y is equal to negative x plus 1, and we need to have a multiple of 1 in front of y, so multiply everything by negative 1 to make this y positive. Y is equal to x minus 1, right? So you see, here you have a negative slope, here you have a positive slope. They must cross each other somewhere, and so y-intercept is 1, slope is 1, so we go 1 to the right, 1 up, and we connect the lines. And here you go. Now you can clearly see the point of intersection. That point is 2, 1, right? So we can clearly see where these two lines cross each other. Now let's make sure that this works. In order for this to work, right, in order for that to be a solution, point 2, 1 must satisfy both of these equations. So when you plug this point in here, they must be true, right? They must be equal to whatever they're equal to. So let's see. Let's plug x is equal to 2 and y is equal to 1. 2 plus 1 is equal to 3. That is true. And the other one, x is equal to 2, y is equal to 1. So 2 minus 1 is equal to 1. Well, both equations are satisfied. Both linear equations are satisfied. That means the system is satisfied. That means this is a point of intersection, and therefore it's a solution to this system. But what if I don't have a lot of time? And what if I don't want to graph anything? What happens then? Well, then for that we have another method, and that method is called substitution. Well, what we do in substitution, the first step is we simplify. So we bring the equations into a form where we know one term. For example, x is equal to something something, y is equal to something something. Then we solve one equation for either variable. For example, we try to find x, or we try to find y first. And then we substitute that into the beginning. So we already have x, for example, we substitute everything back. And we solve for the remaining variable. Now let me show you an example. Such things are learned by solving examples. So let's have a system like this. 3x minus 2y is equal to 6 and x minus y is equal to 1. Now how can I find the solution? Substitution method here. Substitution. Let's solve for x. So the first step should be to solve for one of those variables. Leave it alone. X is equal to, throw y to the other side, y plus 1. Now, we know what x is. X is equal to y plus 1. Take this x, right? Take this y plus 1 and plug it here instead of x. So what we do is we write 3 times y plus 1 minus 2y is equal to 6. Now simplify. Spread this 3 into the parentheses. So 3y plus 3 minus 2y is equal to 6. And now simplify further. So y is equal to 3. We have already found the value of y. For that solution point, y will be 3. Now let's find the x coordinate. So plug this y is equal to 3 back here. So we plug it back, right? Step number 4, solve for the remaining variable. We plug everything back. X is equal to y plus 1, so 3 plus 1, and therefore x is equal to 4. Now, this is our solution. 4, 3 is the point at which two equations have the same value, and therefore two lines intersect. Now, let's try and see if that is correct. So let's see. 3x minus 2y is equal to 6. So 3 times 4, that is 12, minus 2y, that is 2 times 6. 2 times 3, that is 6. So 12 minus 6 is equal to 6. Is that correct? Yes, that is correct. And x minus y is equal to 1. So 4 minus 3 is equal to 1. That is also correct. That means both equations are satisfied by this point, and therefore this is a solution to this system of linear equations. That is this one. Now, for harder systems, or for systems where you cannot leave one of those alone, right? So you cannot either leave x alone or y alone, you may have hard time solving such a system, and therefore we have another method. It's called the elimination method, and it is used when both equations are in a form ax plus by is equal to c. So multiple times x plus multiple times y is equal to c. Right? So the first step is to simplify. Second step, multiply one or both equations by a number that will create opposite coefficients for either x or y if needed. That means we will find some constant to multiply one of the equations in the system to create opposite coefficients, and I will show you in a second what that means. Then we add two equations, so we have a system of two equations, we add them, and then we solve for a remaining variable. For example, let's have a system here, right? We have a fractional system, 1 over 2x plus 1 over 3y is equal to 13, and 1 over 5x plus 1 over 8y is equal to 5. Now, before I work with this, I want to simplify this further, alright? Because I don't like the way it looks. So I want to get rid of those denominators. I want to get rid of those fractions. Therefore, I must multiply each one of those by the least common denominator. In order to find the least common denominator, LCD, we multiply denominators. 2 times 3. Least common denominator for the upper function is 6. Least common denominator for the lower equation is 5 times 8, 40. So let's multiply each of those. So the first one, 6 times 1 over 2x plus 1 over 3y is equal to 13. Multiply everything by 6, that is, open the parenthesis. 3x plus 2y is equal to 78. Alright, so this is our first equation that we will be dealing with. So 3x plus 2y is equal to 78. Now let's multiply the bottom equation by its least common denominator. So 40 times, in parentheses, 1 over 5x plus 1 over 8y is equal to 5. Multiply everything by 40, you get 8x plus 5y is equal to 200. So 8x plus 5y is equal to 200. Now we have a perfect system. No fractions and nothing to distract us. How do we solve this one? In order to solve such a system of linear equations, we must either make this 8 or we must make this 5. So we must have same coefficients. Then we must subtract both equations from each other. So let's make this variable here, let's make it 8. Right? And you will see what I'm trying to do. So in order to make 3 8, we must multiply it by 8 over 3. Right? So we multiply everything here by 8 over 3 in order to make this like this. After multiplying everything by 8 over 3, we get 8 times x plus 16 times y over 3 is equal to 208. Now what we can do is we can subtract this blue equation from that orange one, right? So we can subtract everything here. Think about this like a term-by-term subtraction. So 8x minus 8x gives you 0. 16 over 3y minus 5y, well, that leaves us with 16 over 3y minus 5y. Well, we can simplify this further. Write 5y as 15 over 3y, because these are the same things, and when you subtract everything here, you get 1 over 3y, and that is equal to 208 minus 200, right? Because we're subtracting from the bottom, so that gives us 8. And we got 1 over 3 times y is equal to 8. Wow, we have already found y just by making those the same and subtracting everything, right? And so y is equal to, multiply both sides by 3, you get y is equal to 24. Great, amazing. Now we have the value of y. Sometimes on the SAT you're only asked to find one variable, for example y, and there elimination method is perfect to use. Just eliminate the one that you do not need. Here we didn't need x, for example, so we eliminated it by making those multiples same. But from here you can find x, so you can use either this one here or this one here. Just plug y is equal to 24 in each one of those, alright, and try to find x. Let's plug y is equal to 24 in here, right? And so what we will get is 8x plus 5 times 24, which is 120, is equal to 200. Now 8x rearrange, so throw 120 to the other side, is equal to 80. And so x is equal to 80 divided by 8, x is equal to 10. We have found y and we have found x. So x is equal to 10, y is equal to 24. And therefore the solution here is 10, 24. Alright, so this point right here is the point, is the coordinate where these two lines can cross each other. So that was the way how you solve systems of linear equations. We have seen 3 methods and we have said that 2 of those are effective on the SAT exam. So we may use graphing when we have a lot of time and when we can graph or when we can see 2 lines. We can use substitution when we have a short question where we can solve for either x or y very fast. And we said we can use elimination method when we have harder problems because it makes it easier for us to eliminate something, right? And therefore get rid of either x or y. So elimination method is basically useful when you only need one variable like y or like x. And when you have a system in the form ax plus by is equal to c. Now, sometimes in mathematics we need to use systems of linear equations to solve word problems, that is, written problems. Now, let's look at an example. The cost of a ticket to the circus is $25 for children and $50 for adults. On a certain day, attendance at the circus is 2,000 people, and the total gate revenue is 70,000. How many children and how many adults bought tickets? This question is actually easy when you know how to solve it, and we solve such types of questions when we need to find two variables or two unknowns. We solve those using systems of linear equations. We need to construct two linear equations and then solve and find the solution. That solution will tell us the exact number of children and adults. So let's do it now. The first equation is going to be about money, alright, because we have dollars here. So $25 times children plus $50 times adults. And notice I don't write names here because using shortcuts like C and A is much more efficient. So that is equal to, how much was the revenue? 70,000. So that is equal to 70,000. And now we have come up with an equation for money. What else do we have? We have information on how many people came, attendance, so people, right? And there were children and there were adults, and the amount of people is 2,000 people on that day. Now we have a system of linear equations and we already know how to solve it. So let's solve it together. What we can do here is we can use the elimination method or the substitution method. Well, since we need children and adults, so how many children were there on that day and how many adults were there on that day, right? Since we need two of those variables, using substitution may be a bit better. So let's use substitution. Solve for c first. C is equal to 2,000 minus a. And now we can plug this c right here, right? So 25 times 2,000 minus a plus 50 times a is equal to 70,000. 25 times 2,000, that is 50,000. 25 times negative a is negative 25a. Then we have plus 50a, and that gives us 70,000. Let's have constants on one side and variables on the other side. So 25 times a is equal to 20,000. And from here, by dividing both sides by 25, we get a is equal to 800. Now we have found the amount of adults that were there on that day. So there were 800 adults. What about children? Well, we know the second equation that we have constructed. C is equal to 2,000 minus a. So children is going to be 2,000 minus 800, which is 1,200. There were 1,200 children and 800 adults in that circus on that day. Now here's a practice problem for you. So you may stop the video and try to solve this. The answer to this problem is this: 700 children and 950 adults bought meal tickets on that day. Alright, so this is your answer, and if you found this correctly, then that means you understood how to solve systems of linear equations and how to construct those systems knowing some information. Now, the type of the question that is asked usually on the SAT exam about systems of linear equations in word problems is this. So they have some information, and on the choices A, B, C, D, they have constructed systems of linear equations. We just need to find the one that suits our situation. So let's read the situation first. Remember, in such questions, right? The question begins at the last sentence. Which of the following systems of equations could be used to find the number of tickets for bench seats B? So B is bench seats, right? So when you see B here, that means bench seats, right? And the number of tickets for lawn seats, L. So L is lawn seats that were sold for the concert. Now let's read the statement here. Two types of tickets were sold for a concert. Tickets to sit on a bench during the concert cost $75 each. So again, let's construct an equation for money. So $75 times benches plus tickets to sit on the lawn during the concert cost $40. So plus 40 times L, and that must be equal to dollars, so 19,250. So 19,250. Well, in such questions, multiplication of terms is usually not convenient, therefore this is not the answer. Now we have 75b plus 40l, so this is also not the answer. And we have that equal to dollars, 19,250. So your only choice with the correct answer here is D. Now this is pretty much it. Today we have learned how to solve systems of linear equations and how to construct them for the word problems. We have also went over linear equations and their problems. We have learned the term slope and y-intercept, and we have introduced ourselves to the Cartesian coordinate system. Thank you very much for watching this class. If something was not clear, and if you want to contact me to ask more questions, feel free to do so using my WhatsApp number or the email address. Take care, and I'll see you in the next tutorial.